This video is on modeling with linear equations. Sometimes a real-life situation can be modeled with a linear inequation or inequality. Let's take a look at several examples here. The first says, the cost of a taxi ride depends on the distance traveled. You paid $8.50 for a 3-mile ride. Your friend paid $18.50 for an 8-mile ride. Write and graph an equation that models this situation. So the first thing I like to do when I have a problem like this is I like to figure out what's the independent, which is the dependent variable. Since the cost of your taxi ride depends on the distance you traveled, your independent is going to be your distance, and your dependent is going to be your cost. So I actually have distance and cost for two different taxi rides, so I can go ahead and write two ordered pairs. So for a 3-mile taxi ride, the cost was $8.50, and for an 8-mile taxi ride, the cost was $18.50. So there are my two ordered pairs. Once I have two ordered pairs, I can write the equation of the line. Let's start by finding the slope. So the slope is going to be 18.5 minus 8.5, which is 10, over 8 minus 3, which is 5, or my slope is equal to 2. Now let's get a y-intercept here. So I'm going to use point slope form, so y minus, I think I'm going to use my smaller number here, 8.5 is equal to 2 times x minus 3, or y minus 8.5 is equal to 2x minus 6, and adding 8.5 to both sides gives me y equals 2x plus 2.5. So actually, let's take a look at that equation before we graph it and see what that is saying. So it looks like my starting point is 2.5. So in other words, as soon as I get in the taxi, it costs me $2.50. And then my x-coordinate is the distance or the number of miles that I travel. So every mile that I travel costs me an additional $2. So let's go ahead and graph that. So I'm going to graph my distance down here, and that's in miles, because that's my independent variable. My dependent variable is going to be my cost, and that's going to be in dollars. And I think I can just go ahead and count by ones here. So I'll just label a few things here. There's 2, 4, label a few of those. Okay, so my y-intercept is 2.5, so that would be right here. And then my slope is 2, so I'm going to go up 2, 1, 2, and right 1. Up 2 and right 1. Okay, and I don't know that that's actually going to, my other ride wouldn't fit on there. So is it when I'm at 8? Let's check this out. So when x is 3, okay, when I travel 3 miles, is my cost $8.50? It is, indeed. So there's my graph. Okay, now I guess if I had maybe counted by 2's on the y-axis here, I could have gotten this point 8 comma 1850, but that's okay, it doesn't need to fit on there. Notice that there's not an arrow going in this direction. That would be like negative distance and negative cost, and that just isn't going to happen. So starts here and goes up. Let's take a look at another example here. This one says a fishing boat is 35 miles from the shore. It takes the crew 7 hours to return to the dock. Write and graph an equation that models this situation. So in this case, my time is going to be my independent variable, and my distance is going to be my dependent variable. So this is going to be a time distance. Well, I know that when they start out, they are 35 miles from the shore. So that when their time is 0 hours, their distance is 35 miles. And I know that when their time is 7 hours, their distance from the dock is 0 miles. And I actually like this because this gives me my x and my y-intercept. Notice that this is going to be my y-intercept, and this is going to be my x-intercept. So this is going to be really easy to graph. But let's go ahead and start by writing the equation. So let's start by finding the slope. So I'm going to do 35 minus 0, which is 35, over 0 minus 7, which is negative 7. So my slope is negative 5. Now, does that make sense that I would have a negative slope? Indeed it does, because this fishing boat is 35 miles out from the shore, and every hour it gets 5 miles closer to the shore, so that distance is being decreased by 5 miles every hour. So my equation is going to be y equals negative 5x, and I have my y-intercept here, plus 35. And that makes sense because my y-intercept of 35 is going to be my starting point. Now, I'm not going to graph this using slope-intercept. I'm not going to graph that equation. I'm going to graph using x and y intercepts. But let me label my axes. So this axis is going to be time, and that's going to be in hours. And this axis is going to be distance from shore, and that's going to be in miles. I think my time, I think I'm going to count that in ones. So go ahead and label a couple of those. But now my distance, notice that my furthest distance is 35 miles, so I'm going to count this by 5. So 5, 10, 15, 20, 25, 30, 35, 40. I'm going to count by 5s over there. So my y-intercept is 0, 35, which would be this point right here. And my x-intercept is the point 70, which would be this point right here. And I can just connect those 2 points. And notice again that there are not arrows on the end of this because I'm not going to have negative time and I'm not going to have negative distance. And one more example here. A school has a budget of $240 per classroom to buy workbooks. A math workbook costs $10 and a science workbook costs $12. Write and graph an inequality that models this situation. Because this is going to be an inequality because the most money they have, or the amount of money they have, is $240. They can spend less than that, but they cannot spend more than that. So what we want to find out is how many math workbooks can they buy, how many science workbooks can they buy. So I need to define a couple variables. I'm going to say let x equal the number of math workbooks and let y equal the number of science workbooks. Okay, notice that there's not really an independent and a dependent variable here. The number of math workbooks doesn't depend on the number of science notebooks, or either way. But I do know that each math workbook costs $10. So the total cost of math workbooks is going to be 10x, $10 times the number of workbooks I have. Cost of the science workbooks is going to be 12 times y, because each one costs $12. And the total cost of math workbooks plus science workbooks cannot be greater than, so it's got to be less than or equal to $240. And that's a perfectly acceptable way to leave your equation, which actually makes a lot of sense for this one. Because this looks very much like standard form, I'm going to go ahead and graph this using x and y intercepts. So when x is 0, this goes away, and I have 12y is less than or equal to 240, so y is going to be equal to 20. When y is 0, this goes away, and x is equal to 24. So that gives me x and y intercepts to use to graph my situation here. Again, let's go ahead and label our axes. So I chose x to be the number of math workbooks, so I'm going to put that down here. And I chose y to be the number of science workbooks. And I need to go up to 20 on my y-axis and 24 on my x-axis, so I think I'm going to count this by 3s. And let's do a couple here. Okay, so my y-intercept is 0, 20, which is approximately right here. My x-intercept is going to be 24, 0, which is right here. And I'll connect those with a line. And since my inequality was a less than, it's going to be this region down here. So this is going to be where my solutions lie, which technically I probably shouldn't be shading it because you can't buy a fraction of a math or science workbook. An example of a possible solution to this, let's just pick a point here. Let's pick this point right here. So what that says is that if I buy 9 math workbooks and 6 science workbooks, I actually have enough money to do that because that's going to be less than $240. So in this video, we took a look at how to model with linear equations and inequalities, how to take a word problem, identify independent and dependent variables if necessary, write an equation or an inequality, and then graph that.